Hello, everybody. Today we're going to talk about static electricity. Now, many of you are probably familiar with static electricity because of your experience with balloons. You know that if you rub it in your hair, your hair will then stick to the balloon, and you can then maybe go around and shock other people with it. You may have also rubbed your socks against the carpet and tried to shock your brother or sister. Well, today we're going to talk about 3 different ways that static electricity can occur or be discharged. Now, what I have in front of me here is called an electroscope. And what the electroscope does is it allows us to detect that electric charge has accumulated. So, for example, if I charge the balloon on my wool sweater, the balloon should now have a negative charge. And so when I touch it to the electroscope, now the extra electrons in the balloon are transferred to the electroscope. Okay, doesn't look like it quite happened. Let's try it again. I'm going to rub the balloon. Now there's extra electrons on the balloon. Rub. And touch. Did you hear that little click? That was the sound of a shock or static discharge. So the charges that came from the sweater went to the balloon. Now the balloon has an overall negative charge. And then when I touched the electroscope, the charge transferred into the electroscope. So now this bar here has a negative charge, and this bar here has a negative charge. So they repel each other. You'll notice there's an insulator here, so the charge cannot enter this outer ring. So I'm just going to discharge the electroscope by using something that's a good natural conductor, like a key. There, now I was able to pull the extra charge off the electroscope, and you can see it's now in a neutral position. This time I'm going to charge the balloon, and instead of conducting the electricity to the electroscope, I'm going to do a process called induction. So to show induction, I will charge the balloon by rubbing. Now the balloon has a negative charge. I'm not going to transfer the negative charges to this, but I'm going to use the negative charges in the balloon to influence the charges that are already present in the electroscope. What I mean by that is that this is made of atoms. And so there's positive particles, protons, and negative particles, electrons. Because it's made of metal, those electrons can flow very easily. So when I bring this negative balloon close, it's going to cause the negative particles already in this electroscope to go, run away, another negative charge. Watch, they're running away. They're running away from where there's a buildup of negative charges here. So all the negative electrons that are present in this center bar of the electroscope have headed down towards the bottom, causing this bar and this bar to both be negatively charged. And now they are repelling each other. Now, notice what happens, or make a prediction, what will happen if I pull the balloon away. Look at that. The electroscope goes back to a neutral position. Why? Well, the electrons have now spread back out evenly within here. No electrons were transferred from the balloon. But if I bring the balloon close again, look at that. Again, the electrons towards the top of the electroscope get repelled, really is the right term. They get repelled from the electrons in the balloon, and they go down into these bars at the bottom or at the center. But it's just a temporary position. That's called induction. We're inducing a change from a distance. So induction is a form of static electricity where the charges are impacting each other from a distance without actual touching involved.